Alright, we're going to introduce the idea of recursion here and go through a couple of examples and kind of see what's happening with it. There's a really good video that you can watch that you'll look at that talks about kind of what's happening on the memory side of recursion and specifically how when we have a method, variables, how those are created and where those are stored. And our big problem with recursion is if we don't turn it off. So if we think of recursion really as a loop, trying to solve problems with a different type of loop, it will make a lot of sense, and in some sense a recursive solution is always going to be a really elegant solution, but they can be hard to come up with and especially hard to kind of manage if we don't think about how we actively turn them off. So long story short with recursion is we have a recursive method anytime a method calls itself within a problem. And so you'll see they're easy to identify because at some point in the problem there will be another line of code that loops the method back on itself. And so what we want to do is we need to make sure that we have a non-recursive part as well. So that non-recursive part is often called the base case, and that is what's going to kill the loop. If we don't build in a base case, then it will just continue looping. It will continue making local variables every time we call the method, and if we infinitely make local variables, we pretty quickly fill up our memory and we get this stack overflow error. But this is kind of the starting point. We want to think about how do we turn it off, how do we define that base case, and then how do things proceed as we go through this. And like with other loops, so when we did the for loop and the while loop, you could always take a while loop and write it as a for loop and vice versa. You can solve a recursive problem non-recursively. And sometimes that's going to be more familiar. But if you can find a recursive solution, you'll usually find that that's a much cleaner solution to look at. So there's different ones that you can start with. Traditionally, people do a factorial. And so you could look at factorial as really this repeated pattern, right? So I have n times n minus 1, and if I start with 5 factorial, it would be 5 times 4. And then if I could loop it again to have n be 4, right, it'd be 4 times 3, and I continue to kind of go through those values as we're looking at it. But we got to think about how it's going to set itself up. So this is a recursive program that's going to sum some values. So if we give it the number 5, we go 5 plus 4 plus 3 plus 2 plus 1, and we should get 15 as our answer. Now we can tell that this is recursive because of the red text here. This method will call itself again as we build it back up. So if we pass it a value 5 to start with, it's going to ask, is that number 1? This is our base case. If it's 1, it just sets the result to 1. It gives you back that value. If it's not, then it goes here to our recursive call, and result is going to be ever what the function does, the number, what it was before, plus the recursive piece again. And then at the end, we're going to return the result. So we're going to take a second and run this through our BlueJ IDE with an extension called Jelliet, which will allow us to have a visualization of what's going on behind the scenes here. Okay, so this is an extension from BlueJ that's called Jelliet that allows you to basically take your code. So this is the code that we just saw in the slides. And it's going to be passed a value up here of 5. So we're actually going to give it a value of 5. 5 is going to go in, and it's going to go through our recursive call. So we're going to try to compile this. You can see that this is this kind of stage over here. I guess they call it the theater, and it's going to run through our code. So as we run this, we'll see it's going to create our main method. It's going to pass that value 5 to our value. And it's basically going to ask this question. It's already went through real quickly. It's 5 was not equal to 1, so it went to this part where it was 5, right? Plus, it's trying to figure out the result, and the result is going to basically call num minus 1. So 5 minus 1, slow this down a little bit, is 4, and then that gets passed to sum. You can see that it's now given that back to, I've gotten more variables. So I have another local variable called num and result. And you can see that visually they're kind of stacking on top of each other, right? If we were not to have a base case here, we'd have this stack overflow error where we'd fill up our memory allocation and the computer would shut itself. It would kill the program so that we didn't run out of memory. But you can see these things, every time we have a method call, we're stacking more local variables on top of each other. So it's going to continue to work through it. 4 is not equal to 1. it's going to continue our method call. And there's a 3, that's not 1, so we're going to call the function again. We get more local variables, right? That's going to pass it to it again. We get more local variables. We can see this stack starting on pretty quickly here. We're going to get a 1, right? And once we get the 1, it's going to pass it, and that first conditional is going to be met. So when it passes 1, right, this is now going to be true, result is going to be 1, and we're finally going to be able to return something. Now, one thing that we've noticed is we've never gotten to a return result here. Since this is after these conditionals, we have to finish up this recursive call. All of this has to get dealt with before we can get to this line of result. Well, now that we've got this conditional met, it's going to go on this method to return the result, and then all the other ones are going to go back up and finish up and return the result as we're coming through. So really, sum of 1, which is where we're at, is going to return 1. So it's going to get 1, and then it's going to go back up to the local variable for the call of 2 and start to return those values as we go through it. There's my 1, it's true, it's closing that, and I can see I'm returning 1. And now those are going back up through our calls from before and wrapping up these pieces here. And so now I'm returning my 6, there's my 10, that goes back up, and it's going to go to my original one, where now it's going to be 15. That gets returned, and that actually goes back up to my main method, and that's going to get printed. And so we added up the numbers, 1, 2, 3, 4, 5, and we got 15. If we run it again, so if we were to play this over again and look at the call tree for this, you can see kind of what it looks like as it's branching out. So I'm going to run this here. You can see you run the main, you run sum of 5. It's going through those conditionals again. And it's going to just continue to branch out and build these pieces. So it's going to go all the way through sum of 3, just like before, go down to calling 1. 1 is our base case. That's going to terminate that recursive call, and it'll start returning those statements back up. So you see as it starts working its way back up here, return 1, right? Return 3, because 2 plus 1, and return 6. It's going to return 10. And that at the final part is going to return 15, and then our main method goes from there. So you can see that it branched out. That one recursive call, this piece here, went all the way down here before it came back up and then got to the print statement. Alright, so that's it as we look at recursion. We'll go through another video in a minute about kind of drawing them out by hand, but basically you're taking this idea, this jelly it idea, and then you're going to work it out on paper. Good luck.